The problem statement from GATE Physics 2016 reads as follows. In an inertial frame of reference S, an observer finds two events occurring at the same time at coordinates x1 equal to 0 and x2 equal to d. A different inertial frame S prime moves with a velocity v with respect to x along positive x-axis. An observer in S prime also notices these two events and finds them to occur at times t1 prime and t2 prime and at positions x1 prime and x2 prime respectively. If delta t prime is t2 prime minus t1 prime, delta x prime is x2 prime minus x1 prime, and gamma is this entity, which of the following statements is true? This is a multiple choice question with only one correct answer, and we need to find the correct one. Before we start solving the problem, let's have a look at some relevant concepts. There are some terms which keep coming over and over again in special theory of relativity, and it's good to visit them. So first is the inertial frame. So what are inertial frames? These are those frame of references which are either at rest, that means their velocity is 0, or their velocity is constant. This means velocity is not a function of time. So those are the inertial frames. So usually with every inertial frame there is an observer associated. For instance, let's look at this frame. We call it the S frame, or let's call it the rest frame. This means its velocity is 0. It's at rest. So there is an observer in this frame. So this person O sitting at the origin is the observer for this frame. Similarly, let's talk about another frame S prime. This frame S prime is moving at a constant velocity v with respect to the original frame S. So this is also an inertial frame because this velocity is not dependent on time. And here another observer is sitting at O prime. So what do these observers do? These observers will observe some events. So what is an event? An event is denoted, let's say some event P. This may be ball touching the floor, someone clapping their hands. So this event has some space coordinates associated, let's say x1, y1, z1, and one time coordinate, let's call it t1. The same event will be observed, may be observed by this observer O prime, and we denote it as P prime. So everything is primed in this frame. So this will be x1 prime, y1 prime, z1 prime, and finally t1 prime. Similarly, let's say there's another event Q, which is x2, y2, z2, and t2, and similarly it will be denoted as x2 prime, y2 prime, z2 prime, and t2 prime. So these are two independent events P and Q, which will be seen as P prime and Q prime by this observer O prime. So how are they related? I mean, is there any relation between these two events? Yes, there is. There is an entity called space-time interval which remains invariant across different inertial frames. This means if you calculate this entity delta S for this frame, this will be equal to the entity delta S prime for this frame. So what is this entity? What is this mathematical entity delta S? This can be given by this formula. So this is called space-time interval. We call the first term as time interval. And we call this term as the space interval. Note the space interval is very close to what we are used to seeing as the distance, right? So this is what we call the space interval. Hence the difference of time interval with space interval is the square root of that will be the space-time intervals. Note here the square is here. So that's what space-time interval is. The key thing to note is that the space-time interval remains invariant across different inertial frames. So that is the key thing to note here. Right, just and using this concept we can transform from, let's say, we can get the coordinates of P prime if you know the coordinates of prime, which we call the transformation, and we can obtain it like this. So again, this is the S frame, your rest frame. This is the S prime frame, your moving frame. So let's say if your V is not relativistic, this means V is less than C, then we are habitual of seeing this kind of transformation, right? Time does not change, and x prime will be simply x minus vt. So there is a particle P here with x coordinates x, y, z, and t. Similarly, this event will be P prime, x prime, y prime, z prime, and t prime. We have seen that, right? So, but what happens when we get to very close to the speed of light, when we approach is c, like 0.1 c, 0.2 c, then we can use this concept of space-time interval. We have seen that it remains invariant, and what we can obtain is what is called the Lorentz transformation. So here relativistic means v is approximately c, 0.1 c, 0.2 c, very close to c. So we cannot use the Galilean transformation, that is we cannot get simply by this formula. So using the concept of space-time interval invariance, we can obtain the coordinates t prime and x prime if coordinates t and x are known, where gamma is an entity which is given by this formula. So this is a very straightforward derivation. You can refer to textbooks, but this is the thing that's very commonly used. Right, note that y and z did not change because the movement of this S prime frame was only in the positive x direction. Let's come back to the problem. Before we start solving this problem, let's do some pre-checks. So what are those? We'll check whether all the frames mentioned in the problem are inertial or not. So in the problem there are two frames, that is S and S prime. So this is the frame S, this is the S prime frame. So what's happening is that, so the question says this S is inertial. So S is inertial, that's good. What about S prime? So the question also says that different inertial frame S prime. So S prime is also inertial. So both the frames are inertial. This means we can apply a Lorentz transformation and another formula directly for this problem. Secondly, so this is the S prime. So it says that S prime is moving with velocity v with respect to S in positive x-axis. So I am assuming this to be the positive x-axis. So this for the moving frame, which is the S prime in this case, the speed is v and the direction is positive x-axis. Right. The third thing, we check the number of dimensions in this problem. So in this problem it only talks about the x dimension. The time is there, but in terms of space coordinates only talks about x. So we can say the dimensions is one dimension. In this case it is the x dimension. So this is the summary for these are the pre-checks that we did. And now what I have done is that I have just reproduced the problem here. So this is again the frame S, and I have assumed it to be at rest while the frame S prime moves at a constant velocity v with respect to the frame S, and we were given two events P and Q with the coordinates 0, t and dt here. Correspondingly there will be the two same events here, P prime and Q prime here. We are required to find the time intervals in the S prime frame, that is delta t prime and delta x prime. Now this is a straightforward problem. We know that our Lorentz transformation. So what I can do is, if I need to find delta t prime, I'll do t2 prime minus t1 prime. T2 prime I can obtain here if I put everywhere 2. So it will be gamma. This will be so this will be this will be for T2. I'll put whatever time it is there. So I'll just write it here, T2 minus Vx2 over c square minus corresponding to T1 prime. This will be T1 minus Vx1 over c square. Now let's just put the values. So the value of T2, that is the time coordinate for event Q, is t. So I'll put gamma t minus the value of x2 is d, note that. So Vd over c square minus gamma time coordinate for event P is t again. So this will be t minus Vx1 over c square. This will be V, and the value of x1 is 0. So V times 0 over c squared. So this will be gamma t minus gamma Vd over c square minus gamma t. So minus these two, first and third term gets cancelled. So we will get gamma Vd over c square. So that's the first half of the problem. We found out delta t. Now again, very simple. Delta x prime is x2 prime minus x1 prime. So x2 prime I can write here. It will be gamma x2 minus vt2, and x1 prime would be gamma x1 prime minus vt1 prime. Just put the suffix as 1 as needed. So let's put the value of x2 here. X2, this means x coordinate of event Q, that will be d minus v times t2. This is t, that time coordinate is t here. So vt again minus gamma, the coordinate here is 0 for event P, that's 1. So this will be 0 minus v. So t1 sorry, it's t1, not t1 prime. So vt1, the time coordinate for event P is t. So this will be minus vt again. So I'll solve it. This will be gamma d minus gamma vt minus 0 plus gamma vt. So this and this gets cancelled, so what we'll get is gamma d. So I'm getting delta x prime as gamma d. I'll write in the next slide. So I'm getting delta x prime as gamma d, while I'm getting delta t prime as minus gamma vd over c square. So I'm getting delta t prime as minus gamma vd over c squared. So let's just try to match the answers here. So delta t prime is not 0, so a is eliminated, b is eliminated. So c matches for delta t prime. This is correct, first half. This is also correct. Delta x prime must be gamma d gamma. Yeah, so this is correct. So option C is the correct answer. There's only one option is correct. This is also incorrect. So we found out that C is the correct answer. Yeah, where gamma is this entity, we already know that in the Lorentz formula we have seen in the last slides. Okay, that's it. C is the correct option. Thank you for listening.